Assalamualaikum and hi, my name is Siti NORBA'IAH binti AZMIE, MATRIC ID 23001232. Today, I will be presenting my mini project, which is video for SIF1006 Practical Physics 1. So, let's get started. Alright, in this video, we are going to focus on the learning outcomes for this course. So far, we have 3 of them, which are applying error analysis theory to calculate error in physics experiments. Next, understand the physics theory of mechanics, electricity, and optics in experiments. And lastly, to recognize the best way to present a set of data, which is graph or table, and extract the required information from a graph. So, what are the 5 experiments that we have done so far? The first one is direct current, which is DC1. Experiments about measuring the internal resistance and precision of a galvanometer. Second, alternating current, AC2, determination of impedance of inductor and capacitor using an oscilloscope. Third, O2, which is optics, refraction of light. And next, mechanics, M2, rigidity modulus of wire by using Maxwell needle method. And lastly, M1, which is tension and kinetic friction. Okay, right now, we will go through the first learning outcomes, which is applying error analysis theory to calculate error in physics experiment. Let's take an example from experiment M2. First, we must understand the types of errors, whether it is systematic errors or random errors. Then, we need to identify the measured quantities and calculate their uncertainties as given in the figure. Next, we use the derived formula, which is n is equals to 2 pi m L squared over r to the power of 4 times t2 squared minus t1 squared. Find the value of rigidity modulus of the wire. So we get the rigidity modulus is equals to 7.29 times 10 to the power of 10 kilogram per meter per second squared. After that, we propagate errors using partial derivatives for all variables. Therefore, we get the value of uncertainties of rigidity modulus, which is 4.90 times 10 to the power of 9 kilogram per meter per second squared. Thus, the rigidity modulus is 7.29 times 10 to the power of 10 plus minus 4.90 times 10 to the power of 9 kilogram per meter per second squared. Finally, we get to calculate its percentage error by using the formula measured value minus actual value over actual value times 100. The percentage error is 2.8%. Moving on to the second learning outcomes, which is understanding the physics theory in experiments. So, for experiment 1, which is DC1, measuring the internal resistance and the precision of a galvanometer. The physics theory is related to electricity. It consists of Ohm's law, internal resistance, Kirchhoff's circuits law, which is Kirchhoff current law, KCL, and Kirchhoff voltage law, KVL, series and parallel circuit analysis, potential divider rule, and galvanometer theory. For experiment 2, which is AC2, determination of impedance of inductor and capacitor using an oscilloscope. The physics theory is also related to electricity, but it consists of Ohm's law for AC circuits, impedance in AC circuits, phasor diagrams and phase relationship in AC circuits, and also resonance and frequency dependence. For experiment 3, which is O2, refraction of lights, the physics theory is about optics. It consists of refraction of light, Snell's law, refractive index, and also dispersion of light. Next, for experiment 4, which is M2, rigidity modulus of wire by using Maxwell needle method. The physics theory is related to mechanics, and it consists of torsional oscillations, simple harmonic motion SHM, rigidity modulus or shear modulus, and moment of inertia. And lastly, for experiment 5, which is M1, tension and kinetic friction. The physics theory is also related to mechanics, but it consists of Newton's laws of motion, which is first law, second law and third law, frictional force, tension in a string, and coefficient of kinetic friction. Last but not least, for the third learning outcomes, which is recognizing the best way to present data and extract the information from a graph. So, when to use a table? A table is ideal for presenting precise numerical values such as the tension at specific angles, which is T, average tension, which is T average, and their natural logarithms, which is ln T. For example, in this experiment, the table shows exact value of T and ln T for angles ranging from 0 degree to 720 degree. Tables are helpful when you want to compare experimental values with theoretical values or calculate percentage errors. A graph is better for visualizing trends and relationships in the data. In this experiment, plotting ln T against theta, which is angle, helps us see how tension decreases exponentially as the angle increases. For example, the graph of ln T versus theta shows a linear trend where the slope represents minus or negative mu, which is the coefficient of kinetic friction. This makes it easier to extract meaningful insights compared to just looking at numbers in a table. So, how to extract information from a graph? We must first understand the axis. The x-axis represents the angle theta in radians, while the y-axis represents ln T, which is the natural logarithm of tension. Knowing each axis will help us to interpret how tension changes with angle. Next, we must identify the trends. From 0 degree to 360 degree, the graph shows a steady linear decrease in ln T, indicating that tension decreases exponentially with increasing angle. From 360 degree to 720 degree, the decrease becomes steeper, showing that tension becomes more sensitive to angular changes after one full rotation. The slope of the graph gives negative mu, which is used to calculate the coefficient of kinetic friction. For example, by applying linear regression to the graph, we can determine mu directly from the gradient. The graph allows us to compare how tension behaves across two angular ranges, which is 0 degree to 360 degree and 360 degree to 720 degree. In this experiment, tension decreases more rapidly in the second range due to cumulative effects like energy dissipation. The graph confirms that tension decreases exponentially with angle due to kinetic friction. It also highlights differences between initial and later cycles, showing how friction's effect accumulates over time. I think that's all from me. Thank you for watching this video. Bye!